Hello everyone. Previously we had discussed on the merge intervals algorithm, right? So today we'll be discussing on the MOS algorithm, right? So let's get into the definition part first. Let's see what it states. So MOS algorithm is a query optimization technique, right? So this is basically a query optimization technique used on the static arrays to answer range queries, right? So again, MOS algorithm is query optimization technique used on the static arrays to answer range queries like sum, frequency, distinct count, etc. efficiently, right? So this is one of the things we have to keep this in mind. It sorts the queries in a special order and answers them in the approximately big of n plus q into square root of n time. Again, it sorts the queries in a special order and answers them in approximately because n plus q into square root of n time. Simple, right? So let's imagine that we are asked multiple queries on an array, right? So let's imagine we are asked multiple queries on an array, right? So let's go with the example query. Example query, well, what is the sum of the elements from index L to R? That's what we'll be going with. And if we compute each query separately, it may take big of n into q, which is too slow. So here, most algorithm improves efficiency basically by dividing the array into blocks of size square root of n, right? So first what it does, it improves the efficiency by dividing the array into blocks of size square root of n. The second thing is, it also sorts the queries by block index and then by r, right? So maintaining a current range, nothing but current L as well as current R, right? Left and right we have given here. So finally, what we'll do, we'll update or shrink the range while moving from one query to another, right? So we will update the results efficiently and big of 1 or big of logarithmic n time per shift, right? So this is what we'll be doing. So this, I just said this step by step. So this is what we'll be doing in the algorithm. So I'll just explain clearly when we write the algorithm, right? So this way, instead of recalculating for each query, we will be reusing the previous calculations by moving the range endpoint smartly, right? So that's what we'll be doing here. First, what shall we do? Let's go with the algorithm. So I'll just explain this step by step. So we'll try to understand whatever I have said this one from here. Basically, imagine we are asked multiple queries on an array, right? So from here, whatever we had discussed, the same thing, let's try to understand in the form of code, right? So first, let's go with the simple MOS algorithm example, and basically let's go with the programming language Python, right? So problem is nothing but, so we are given an array and multiple queries L comma R, right? So we have to find the sum of elements in the range efficiently, right? So let me go with math first. Let's import math. So here first one is, let's go with the import array one. Sorry, import array, not the import array. So I'll just go with array equals, let me go with 1 to some random numbers right here. Let me go from 1 to 9 actually. Sorry, this is fine. 9, this is fine. uh the next thing, sorry, the next thing here would be, let's go with the step 2, nothing but queries in the form L comma R. So I'll just go with queries. uh yes, this is fine. Now let me go with, first let me go with 0 comma 4. Second, let me go with 1 comma 3. This is also fine. Third, let me go with 2 comma 8. So this is also fine. Fourth, let's go with 0 comma 8 here. So this is also fine. So now, first we have considered the input array. Next we are going with the queries in the form L comma R, as we had discussed. Now let's pre-compute the block size that is equivalent to the square root of n, right? So this one, this step, dividing the array into blocks of size square root of n, right? So this one, first step, let's go with that. So I'll just come here. Let me leave a line space here. So now let's pre-compute the block size equals square root of n. So this is nothing but length of, let me pass the array here, and next, so I'll just go with the block size, and let me go with int. Let me pass here, we have imported math, right? So let's go with the square root here. Math dot square root of, let me pass n. This is fine. Now that's fine. Let's move on with the next step. Next step, what we need to do here, here, yeah, we sorting the queries by block index and then by r, right? So let's sort now. Let's sort the queries by block and then by r. When I say this, let me go with queries with index. So let me assign this one too. So within the array, so I'll just go with l comma r comma index. So this is fine for index. So this is also fine. So this one will be l comma r. So this is also fine in enumerate. So this one, let me pass queries. This one, this is fine. Now again, let me go with a queries with index. So we have to sort, right? So I'll just go with sort. So let me give key here, key equals, let me pass lambda. This is fine. uh, let's go with x. So this one will be x of 0, x of 0. So x of 0, after this, mhm, we have to pass block size. I have already given, right? So this is fine. Block size, comma, x of 1, right? So we have successfully sorted the queries by block and then we are doing it by r. So this is fine. Now we are done with this part. So now we have to answer the queries using most algorithm, right? So then what we need to do, so we have to maintain the current range, expand or shrink the range while moving from one query to another, finally update the results and big of one, big of or big of login time per shift. So these 3 points in simple terms we have to answer queries using the Morse algorithm, right? So that's what here. First we have to maintain a current edge, current l comma current r. Let's see the same thing in the form of code here. So now I'll just consider current l. So this one current r, so this is fine. Then I'll just consider current left, current right. I'll go with the current sum that is equivalent to 0, also minus 1. Let me go with the 0 as well, right? So this is fine. Now let me go with answers and let me assign this answers to 0 into, so this will be length of, let me pass queries. So this is fine. Now what shall we do? Let me go with a simple for loop method. So I'll just go with for l comma r comma index in queries. So we have to consider queries with the index, right? So I'll just go with queries with index. So we have already written this one, right? So this is fine. First we have to move the current l, nothing but current left, right? So for that I'll just write simple while loop here, right? So while loop, while this one will be current l. So if it is greater than l, this is fine. Next what we'll do, current l equals current l minus 1. So this is fine. Now current sum, let me consider current sum equals current sum plus array of, so this one will be current l, right? So this is fine, man. Now let's do one thing. Now we have to move the current right as well. So let me copy the same thing and make the necessary changes here. So this one, so instead of left, so this one will be right, current right. So this one, instead of greater than, this one will be less than r, basically not l. So this one has to be r, not sorry, uh, let's consider big r here. So I've considered big r itself, right? So this is fine. This one has to be current right equals current right plus 1, not minus 1, as we are dealing with the current right, right? So we have to move the current right side, basically current r right side. Basically first we moved current l left side, now we are moving current r right side. So this one will be this one will be current sum equals current sum plus uh, array of current right. So instead of l, I'll just go with the r. So this is fine. Next what shall we do? We have to move current left right. That is also one of the thing, right? So current left we have moved left, current right we have moved right. Now let's move the current left right and current right left, right? So now how can I write that one? So again, so let me paste this one. Again, let me come here, let me paste this one. These two things, let's make the necessary changes. We have to move the current left, right, current L, right. So I'll just go with current left, uh, current left. It is, if it is less than L here, then current sum equals current sum minus. So this one, did I miss anything? No, right? Current sum equals current sum minus array of, uh, yeah, current L. This is fine. So let me copy, let me cut this one entirely one. So let me paste this one over here. So this one has to be current L equals current L plus 1, as we are moving the current L right side, right? So same, let's do the same thing for the this one, current R. Let's move the current R left. So this one has to be current R. So this one has to be greater than R. This is fine. Next, so this current sum has to be current sum minus, current sum equals current sum minus array of current R, right? So current sum equals current sum minus array of current R. So this one has to be R. This is fine, man. This is fine. Now let me cut this one entirely. Now let me do one thing. Let me paste it over here. So this one will be current R equals current R minus 1. So this is fine, man. Yep. Now let's do one thing. We have to store the result, right? So we are done with that for part. So this is it basically. Now let's store the result. So I'll just go with the answers variable here. Answers of, let me pass index. We have already considered answers and index both. So let me assign this one to the current sum. So this is fine. So finally we are left with only one thing. We have to print the results in query order, right? So I'll just go with, when I say query order, I'll just go with for I, comma, I have considered ANS, right? So ANS variable. So this one, and enumerate of answers. So this one, let me pass answers here. This is fine. So let me do one thing. Let's print something. I'll just go with print f followed by query. This is fine. Let me pass I. This is also fine. Now let me go with sum equals answer. This is fine, man. Yep. We are done with the coding part. Right. So we are done with the coding part. So this is it. We have went step by step. First, what we did accordingly. So we went with dividing the array into blocks of size square root of n. So you can clearly see here this part 30, 31. Then we went with sorting the queries. This one we went with maintaining a current. Before this one, we went with this part, right? So just give me a second. Yeah, sorting queries by block index and then by R. So this is nothing but 33 and 34, right? So next, we went with this one, these 3 points, basically maintaining a current range, expand or shrink the range while moving from one query to other. So basically we went with move the current, this one L left, move the current R right, move the current L right, and move the finally move current R left. That's what we did, right? So then update the results efficiently in pick of one or pick of logarithmic and time per shift. So exactly we followed the same steps, right? So same thing. So this way, what we are doing basically, instead of recalculating for each query, we can reuse the previous calculations by moving the range endpoints smartly. So this is where this one, most algorithm plays a this one vital role, right? So this is range queries for the static array. So just remember this one. We cannot consider this one for the dynamic arrays, right? So this will be helpful only on the range queries on the static arrays, right? So see here accordingly with the definition as well, most algorithm is query optimization technique used on the static arrays to answer range queries, like whether it may be sum, frequency, distinct count, anything, right? Efficiently, it sorts the queries in the special order and answers them n approximately because of n plus q into square root of n time. So this is fine, man. So basically just remember this will be applied on the static arrays. This will be very helpful when you are giving contest, right? So if you want to apply Morse algorithm anywhere. So just remember the point. First point to remember itself is it will be applied on the static arrays, right? So we can apply Morse algorithm on the static arrays, not the dynamic arrays. And one more thing, dynamic things. Basically, uh, it's a query optimization technique. Just remember that, and you have to just remember these three things. So you can just make the changes accordingly with the problems they have asked, right? So you can just apply the algorithm. So this is fine, I guess, right? So this is it for the code. So when I run this, we have considered the example 1 2 3 1 to 9 basically, right? So the queries are query 0, query 1, query 2, and query 3. So accordingly we are displaying, right? So see here, query of I is nothing but this will be index first query, this query with the indexing starts from 0. This is nothing but the query 0. This will be query 1 and query 2 and query 3. So for this query 0 to 4, 0 to 4 means 0 1 2 3 4. So this one we have to add. So this one, see here, let's add this one. 5 plus 4 equals 9, 9 plus 3 12, 12 plus 2 14, and finally this one is 15, right? Finally this one is 15. So the output for the first query we have to get here is 15. This is why. Next we are going with query 1. So this is for the query 0 basically. So this is for the query 0. So this one 1 3, it consists of 1 3. So 1 to 3 means 1 2 3, right? 0 1 2 3, 1 2 3 means from we have to add from 2 plus 3 plus 4 basically. 4 plus 3 7, 7 plus 2 9. So 9, this is for the query 1. And for the query this one, what do we call, for the query 3, so this one we are going with 2 to 8. 2 to 8 means this one 2 to 8 completely, right? So this one 2 3 4 5 6 7 8, basically we have to add from the element 3 to 9. 3 plus 4 will be this one. 4 plus 3 7, 7 plus 5 12, 12 18, 18 plus this one 25, 25 plus 8 nothing but this one 33, 33 nothing but 33 plus 9 42, 42 we have to get here. 42 here in this case, this is for the query 2. And finally we'll be going with the last query, nothing but the query 3 here. So query 3 we have from 0 to 8, 0 to 8 completely. We are adding entire this thing from 0 to 8. So this will give us 45. So here we have already added from this one 3 to 8, right? So sorry, 2 to 8. Now we have to just add this one, these two. 2 plus 1 3, nothing but 42 plus 3 is nothing but 45 here in this case. So now 45, this one we have to get for query 3. So the output that we need to get here is 15 9 42 and 45. Let's check the same while I run the code. Just remember this one, right? So output is fine. So now let me explain whatever the code that I have written, right? So again, so that we don't forget this one, right? So we should be able to implement the same when we are asked certain problem basically. Just when we know that this particular problem can be solved with a Morse algorithm, nothing but this is the problem to be solved for the this one range queries. When we are dealing with the range queries on the static arrays again, right? So Morse algorithm is query optimization technique used on the static arrays to answer range queries, whether it may be sum. In our case, for the example, we have considered sum. It may be for the sum, it may be for the frequency, it may be for the distinct count, anything, right? Efficiently. So it sorts the queries in the special order and answers them in approximately big of n plus q into square root of n time. Just try to remember this one, man. Fine. Yeah. Now let's do one thing. Yep. Let me explain this one very quickly so that we don't forget things, right? So this one from first. So this one again, line number 27. So this one array is our input array, right? So this one queries whatever I have given. So this one is nothing but the queries with L comma R indices, right? So this is nothing but left index and this is nothing but the right index. Just remember this one, L comma R indices mainly. So block size equals square root of n, whatever I have given here. This one block size equals this one, whatever I have given. This is size of each block. And queries with index I'm going with next, right? So this one queries with index, basically this one we are attaching the original index to each query. We know this one, right? So we are attaching the original index to the each query. So this is important because we have to store the order later. We have to store the order later. That is the reason we are considering this one, queries with the index. So you may ask, this is not required at all. Why we are making use of the queries with this one index? because we have to store the order later, so that is the reason we have made use of the queries with index. So this is very important, right? So next we are going with a sort means we are sorting the queries first by block. See here, this part I'm speaking of, right? So this is fine. We are just sorting the queries by block, nothing but L double slash block size I have given, right? So we are sorting the queries first by block, then by R, then by R, right? So accordingly with this point, this one, sorting queries by block index and then by R. This is fine. Next, what we have done here, so we have made use of the current left, current right, and current sum, nothing but curl, this one R, and sum, whatever I have made use of. This is nothing but the current left, right, and sum. Initially range is empty. We know that initially range is empty, so we have assigned this one to 0, -1, and 0 respectively. Current L 0, current right, this one -1, and current sum 0. Initially they are empty, right? So this is fine. Now the while loops, basically whatever I have made use of here within the for loop, I have made use of the while loops, right? So for while loops, so this one I have explained while writing as well. So this one adjust the current range, nothing but the current left comma current R. So this one current left comma current R, this adjust the current left and current right to match each query left comma right. Just remember this. And we are expanding the right, nothing but it adds the elements to sum, and we are shrinking the right which removes the elements from sum. We are expanding the left that subtracts elements, and we are shrinking L that adds elements, right? So that's what we are doing. See here, first step, second step, third step, nothing but 48, and the fourth step nothing but 52. So this one I'm speaking of, right? Finally what we are doing, we are storing the sum for each query in the answers of index. This one I'm speaking of 56. Finally we are printing the answers in original order, 58 and 59, right? So I hope this part is completely clear, man. We know what the output that we need to get here. What is the output that we need to get here? So let's try to run the code. I'll just give here Python. So let me copy this one, file name dot py, right? See here, query 15 we are getting, so I showed that one, right? So 15 correct output we are getting. The second one we are getting 9, which is absolutely correct. Third one nothing but the query 2, the indexing starts from 0, right? So I'll just go with query 0. This one query 0 we are getting 15. Query for the query 1 sum we are getting 9. For the query 2 the sum we are getting is 42, and for the query 3 the sum we are getting is 45. We are getting the desired output. So the algorithm works absolutely correct, right? So it does our job. It does our job, right? So whatever we wanted, basically what we are dealing with, again we are going with a query optimization technique here. We are applying the query optimization technique on the static arrays, right? On the static arrays 0, 4, 1, 3, 2, 8, 0, 8. So queries basically, right? So on the static array, see here, array is this one, static array 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So to answer the range queries this one, right? 0, 4, 1, 3, 2, 8, 0, 8, right? So to answer range queries, like whether it may be sum, for this particular example we have went for the sum, we can also go with frequency, distinct count, etc., right? Efficiently, again it sorts the queries in special order and answers them in approximately this. Just remember this one, this is important as well, right? So approximately because of n plus q into square root of n time, right? So this is fine. We are done with the, what do we call, Morse algorithm, right? So I hope the Morse algorithm part is completely clear. Morse algorithm, so let me summarize whatever we have learned so far. MO, or the Morse algorithm, it is used for the efficient range queries on static arrays. Just remember this, these 4 points, these are very important, man. Again, Morse algorithm is used for the efficient range queries on static arrays. This is one thing. It reduces complexity from big of n into q to about big of n plus q into square root of n. So this is one thing. The third one is it works best when updates are not required. Means updates are not required in the sense when we are dealing with the static arrays, right? So this one I have stressed this one multiple times. We will be going with a Morse algorithm on the static arrays only most of the times, right? So just keep this in mind. this works best when updates are not required, means when we are dealing with the static arrays. So the main trick is to sort the query smartly and adjust the current range step by step. So that's what we have done. So while loop, whatever we have considered here, for while loops, so we are sorting the query smartly here. So this one, before this one, we have sorted here this part, right? So we are sorting the query smartly and adjusting the current range step by step. Current range in the sense this one, while loop, whatever we have written within the for loops, this is fine, right? So this is the trick, basically sorting the query smartly and adjusting the current range sum step by step. Again, so this is to be applied only on the static arrays, right? So this is used for efficient range queries on static arrays. And remember the time complexity that I mentioned. So complexity, and also remember that this works best when updates are not required and when we are dealing with only static arrays. And the main trick here is to sort the query smartly and adjust the current range step by step. So remember these points, man. These points are very important, right? So we are done with the MOS algorithm for today. This is it. Next, so this is it for today, right? So tomorrow we'll be discussing on the topic or the algorithm, this one, Boyer Mori majority vote algorithm. So tomorrow it will be the last topic on the array algorithms, right? So from day after tomorrow we'll be dealing with the string algorithms, right? So let's finish it off tomorrow by um, this one, discussing the Boyer Mori majority vote algorithm, right? So for now, this is it for the most algorithm. Thanks for watching, guys.